HVAC Temp-Rise formula lets you calculate actual airflow in cubic feet per minute by measuring supply and return temperatures and applying a simple, repeatable equation. Measure steady-state temperatures after 15 minutes of operation with the system set to the exact fan speed tap you intend to test. Record supply temperature at the supply plenum and return temperature in the return plenum or the return grill. Use a calibrated thermistor or thermocouple with at least plus or minus 1 degree accuracy and hold the probe steadily without touching metal. Calculate temperature rise as supply minus return in degrees Fahrenheit, then use the standard specific heat constant of 1.085 for air and the system's sensible heat setting. CFM equals sensible heat divided by the product of 1.085 and the temperature rise, where sensible heat is the burner input minus estimated combustion losses for gas or the rated heat output for electric. For cooling, use the measured sensible cooling in British thermal units per hour. If blower speed tap selection is uncertain, first verify line voltage at the furnace motor and trace the tap wire colors to the manufacturer's wiring diagram. Then change taps with power off and confirm continuity to the chosen tap before restoring power. Account for duct leakage by pressurizing the system or performing a quick smoke test at long runs. If supply temperature is anomalously low for the calculated CFM, suspect bypass, or return leakage, and seal registers or access panels. Adjust for filter restriction by measuring static pressure across the filter. If static rises above the manufacturer's recommended limit, clean or replace the filter and repeat the temperature rise test. For multi-speed motors with electronically commutated motors, use the motor control board settings and observe the fan command signal rather than assuming tap markings correspond to discrete speeds. Consult the motor datasheet for torque versus speed curves to refine CFM estimates. Always repeat measurements 2 more times under the same operational mode and average results to reduce transient error. One of the most common mistakes is incorrect temperature measurement technique causing bad airflow readings. Fix that by using insulated probes, measuring at least 3 inches into duct flow, and averaging readings after stabilization. Another frequent issue is testing on the wrong blower speed tap so results do not reflect intended operation. Fix by powering down, selecting the correct tap as per the control diagram, and rechecking line continuity before testing. The third issue is ignoring filter and coil restrictions that reduce effective CFM and skew Temp-Rise calculations. Fix by measuring static pressure across the coil and filter, cleaning or replacing obstructing elements, and accounting for those losses in your sensible heat input. BigHomeProjects.com is a searchable directory that helps homeowners find trusted local HVAC contractors who can perform accurate Temp-Rise and airflow testing. Contractors get visibility and qualified leads through our platform, so skilled technicians can connect with homeowners needing precise airflow diagnostics.